Algebra 2, Unit 3, Day 3. Let's get right after it. Okay, so we've been solving systems of linear equation. In Day 1, we looked at graphing the two lines and seeing where they intersected, if they intersected at all. In Day 2, we looked at taking the equations and using the substitution method when there was just an x or y that we could isolate nicely. Well, now we're going to look at the third and final way to solve linear systems that we're going to look at this year. My favorite, which is elimination. It just sounds like cool. We're going to do some elimination. So here we go. For elimination, here is a grade school version of the premise that we're working with. Okay, so here's something that we all remember from back in the day. 4 plus 1 equals 5. That's a true statement. Let's do another one. 2 plus 6 equals 8. Okay, so there's two true equations. Okay, two true equations. Now, what if I add each column of terms in the equations? Okay, now I'm going to keep the equal sign on top of each other. So I'm going to bring an equal sign straight down here. I'm going to add the 4 and the 2, and I get 6. I'm going to add the 1 and the 6, and I get 7, and it's positive, so I'm going to go plus 7. And then I'm going to add the 5 and the 8, and I get 13. Okay. The only thing I want you to notice and understand is that this is a true statement. This is a correct equation. So when you have two equations, you are allowed to add them together so that you get a third correct equation, right? Well, why is that important? Well, over here, we have two linear equations, and instead of using substitution to solve for one of the variables, okay, which actually eliminates the second variable, we're going to eliminate one of these variables by adding the two equations together. Okay? So I'm going to rewrite these off to the side. 2x plus y equals 10. So we have an x term, we have a y term, we have a constant. Negative 5x minus y equals negative 19. Again, an x term, a y term, and a constant. Please notice we line up the x terms, we line up the y terms, we line up the constants, and then one other piece that's very important, we line up the equal signs. Don't forget to line up the equal signs. Okay, so first thing I'm going to do here is I'm going to notice that I have a positive 1y and I have a negative 1y. So I know that if I add those two equations together, my two y terms are going to cancel and the y will be eliminated. All right, so I'm going to add these two equations together. So let's see what we get. We have 2x plus negative 5x, which will give me negative 3x. We got positive 1y added to negative 1y, and since they're opposites, they cancel to 0. So it's like negative 3x plus 0. Now I'm going to bring my equal sign straight down. Do not move the equal sign. I'm telling you, don't move the equal sign. And then 10 added to negative 19 is negative 9. So we got negative 3x equals negative 9. Now I can rewrite this a little bit closer. Okay. If you want, don't need to. Okay, so here we go. Divide by -3, divide by -3. So notice we have eliminated the y. There are no y's here. There's just x term and constant term. So we divide by -3. Here, that cancels down to 1x. -9 divided by -3 gives you 3, right? So now, just like in substitution, we're going to take that 3 and we're going to substitute it into either of the original equations, and we're going to solve for the other variables. So if x is 3, let's use this first equation. So let's say we've got, let's go with a different color. Let's go red. Let's go with 2 times x plus y equals 10. Okay, now what is x? X is 3. So we're going to take this x, we're going to put it right there. 3. Okay, now let's just simplify and solve for y. So 2 times 3 is 6. Let's subtract both sides by 6. Canceling that 6 out nicely. So I got positive y equals 10 minus 6, which is 4. Okay, so that means if I graph these two equations on a graphing calculator, they will intersect at the point 3, 4. Don't forget to check your answers. Don't forget to check your answers, right? Substitute your 3 in for the x, substitute your 4 in for the y, and do it to both equations to make sure that they are true equations. Okay? If you do forget it, you might unnecessarily lose points on an assessment, and I don't want that, and you don't want that. Okay, so let's look now at a couple more examples. Now, why are these examples a little different? Well, because if you look at the x terms, they're not exact opposites. Okay, it's not like you have a negative 2x and a positive 2x. If you look at the y terms, they're also not opposites. You got a negative 9y, and there's no plus 9y underneath of it. Okay, so that's why this topic says we are not just going to be using addition, we're going to have to do a little multiplication, because we want to find the lowest common multiple, the LCM, the least common multiple or lowest common multiple for, and you get to pick either the x coefficients or the y coefficients. Either way is fine. You're going to get the right answer, whether you choose x first or y first. Okay, so we want the two coefficients, let's say of x, to be opposites. So if I have a negative 2 and I have a -5, what is the lowest common multiple for those two numbers? In other words, the number, the smallest number preferably, that -2 will multiply evenly into, and -5 will multiply evenly into. Okay, -2 and -5 can both be factors of, okay, hopefully you're saying 10. We can get 10 out of that, right? Now, I would like for one of the two terms to have a 10x and the other term to have a -10x, because then when we add them, they cancel. They are eliminating the x. So let's do that. So I'm going to rewrite this first equation. I want the first term to be 10x. Well, it used to be -2x. Now it's 10x. How did we go from -2x to 10x? We multiplied by something. -2 times what gives you +10. And hopefully you're saying -5. And that would be absolutely correct. I'm going to multiply this first equation by -5. So -5 times -2x is +10x. Negative 5 times negative 9y is positive 45y. If you're going to make mistakes, it's probably going to be in this step. So pay close attention, go back and rewind it as much as you need to. Bring your equal sign. Negative 5 times 17 is negative 85. Okay, so I've rewritten the first equation, and I used red. Let's rewrite the second equation. Let's use blue. So I would like this one to have a negative 10x, so that if I add the two equations, the two opposites will add together to give me 0, and that'll eliminate my x. Okay, so how did I go from negative 5x to negative 10x? What do I multiply by? Simple, I multiply by 2. So let's do that. Let's multiply the entire second equation by 2. So I got negative 10x, and then minus 3y times 2 is minus 6y. And then negative 16 times 2 is negative 32. Okay, so this is all set up nicely. Now it looks a lot more like the original question where we had two y terms that were exact opposites. Now we have two x terms that are exact opposites. So I can just add these two equations together. Add the x to the x, the y to the y, the constant to the constant, and bring your equal sign straight down. Okay? All right. So 10x plus negative 10x gives you 0, which is a cancel. Okay? 0x is just 0, so I don't need to bring it down. Next, I got plus 45y added to minus 6y. Well, 45 plus negative 6 gives you positive 39y. Okay. And then finally, negative 85 plus negative 32 gives you negative 117. Cool beans. Okay, 39y equals something. Well, let's do our one-step algebra. Divide both sides of the equation by 39. So 39 divided by 39 is 1, 1y, it's just y, equals. Now, negative 117 divided by 39 is going to be negative 3. So we've got the toughest part, I think, of our answer. We've got our y coordinate. We've done our elimination by multiplying and adding, and now we've solved for y. Now let's substitute negative 3 for y, and we'll pick either of these equations, the first equations that we got. Let me see. Let's take the first one. All right, I'm going to take that red equation, so I'll go back to red. So I got negative 2x minus 9y equals 17. What was y? Well, it was this little guy right here, negative 3. So I'm going to substitute that right there where the y was. Okay, so let us simplify. Okay, so negative 2x minus 9 times negative 3 is a plus 27. Now we're back to old school. Subtract 27. We've got negative 2x. We got negative 10. So if we divide both sides by negative 2, okay, you've got x equals negative 10 divided by negative 2, which is 5. So that tells me that my answer should be 5, comma, negative 3. So if we graphed the two original linear equations on a graphing calculator, they would intersect at 5, negative 3. Okay, so check your answer. Don't forget to check your answer. Substitute your x for the x, okay, in this case 5. Substitute the negative 3 for the y. See if 10 times 5 plus 45 times negative 3 really does give you negative 85. I think it does, okay? So On tests and quizzes, please check your answer. You should never give me a wrong answer because you can check yourself before you wreck yourself. Okay, number 2. Let's look at these. We could choose to find the lowest common multiple for these two, or we could choose to find the lowest common multiple for these two. Well, they're about the same as far as which one is easier. Let's say that since we eliminated X with question 1, just for the heck of it, let's eliminate Y with question 2. So I want the lowest common multiple, or the least common multiple, between positive 3y and negative 4y. Okay. I would like for those to be opposites. So 3 and 4, what's the lowest common multiple for 3 and 4? The smallest number that 3 and 4 are both factors of, well, you can always do 3 times 4, and you get the right answer on this one. The lowest common factor, or common multiple, is 12. Now, it would be cool if we could have a plus 12y and a minus 12y. That would be neat, because then we could add them together. Bing, bang, boom. We were eliminating one of the variables. So let's do that. For the first equation, let's take that plus 3y and make it a plus 12y. Well, what do we multiply positive 3y to give you positive 12y? And hopefully you're saying 4. Okay? So we're going to multiply this first equation by 4. So 4x multiplied by 4 gives you 16x. Plus 3y multiplied by 4 gives you plus 12y. Bring your equal sign. Negative 1 times 4 is negative 4. Okay, let's do the same thing with the second equation. I want that minus 4y to become a minus 12y. Okay, so in order to have that minus 12y, what do I have to multiply minus 4y by? Hopefully you're saying 3. So 3 times the second equation will give us that minus 12y. Okay, now let's find the other two terms. So 3 times negative 7x will give you negative 21x. Bring your equals. 3 times negative 2 is negative 6. Okay, so let's add straight down, add vertically. 16x added to negative 21x gives you negative 5x. Positive 12y added to negative 12y gives you 0. So it's plus 0, which I'm not going to write. Bring your equal sign straight down. Negative 4 plus negative 6. Well, that would be negative 10. Okay, we're going to divide by negative 5, divide by negative 5, and I get x is equal to 2. Okay, we found one of the variables. We're going to substitute that value in and solve for the other variable. Let's take the 4x plus 3y equation. So 4x plus 3y equals negative 1. Well, we know what x is. It's 2. So we're going to put that 2 right in here. 4 times 2 is 8. Let's subtract our 8. I get 8 minus 8 is 0. 0 plus 3y is just positive 3y. Negative 1 subtract 8 is negative 9. Let's go right ahead and divide by 3. Divide by 3. Okay, and we get y equals negative 3. So that tells me that if I were to graph these two equations on a graphing calculator, that the intersection or the solution would be the point 2, comma, negative 3. Okay, we're rolling. All right, Now, if you do this next part right, this is the easiest part of this section, right? Your answers are going to be 0 solutions, 1 solution, or infinitely many solutions, okay? Let me give you an example of each. If I say we have 1 solution, an example of that might be x equals 2. And then you would find what y is. If I say you have 0 solutions, an example of 0 solutions might be 0 equals 3. 0 can't equal 3. 0 never equals 3, so this equation is never true. And then if I give you something where I say we have infinite solutions, well, that might look something like this. 0 equals 0. When is 0 equal to 0? Always. So always true means there are infinite solutions. Okay, with that in mind, let's take a look at doing a little elimination here. Now, can we just add or subtract or whatever we want to do here right off the bat? Well, the equal signs are lined up. That's important. Equal signs are lined up. You have x's on top of x's and y's on top of y's and constants on top of constants. All right. Is there anything here that we can just eliminate by adding? I'd say, yeah, look, we got plus y and minus y. We have 2 opposites. So let's go ahead and add these 2 equations and see what true equation we get from them. So if I add negative 3x plus negative 3x, be careful on this. People are going to get this wrong. Negative 3 plus negative 3 is not 0. Okay? Negative 3 plus negative 3 is negative 6x. That's an x. Trust me. Okay. Positive y added to minus y. Cancel. 0. Negative 6 plus negative 6. It's not 0. Okay. Negative 6 plus negative 6 is negative 12. Okay. Let's divide both sides by negative 6. Okay. So we get x equals 2. Wow, that's a coincidence. So x equals 2. Okay, when does x equal 2? One time, and that's when x equals 2. Sounds easy? Good, it is easy. Okay, how many times is x equal to 2? One time, when it's equal to 2. But it does say give the entire solution. So if x is one certain number, then just like all of the other equations that we had in the previous 3 days, these systems are going to give us an x and y coordinate if we have one solution. So let's take that x equals 2. Let's substitute it right into this first equation's x. So negative 3x plus y equals negative 6. Okay, we said x is 2. So we'll put 2 right here. So negative 6 plus y equals negative 6. Let's go ahead and add 6 to both sides of the equation. And we got those 6's cancel. 6 and negative 6 cancel. So we got positive y equals 0. So that means if I'm going to graph these 2 lines, they intersect at the point 2, 0. That is one solution. Okay. So let's see what the answers are for Alex here. The system has no solution. The system does have a solution. The system has a unique solution. Yes, it does. And that xy is 2, 0. Okay, the system has infinitely many solutions. Nope. One solution, only one solution. These 2 equations are satisfied only when x is 2 and y is 0. Okay, let's look at question 2. All right, do we have anything that can be eliminated right now? We don't know. You know why? Because the equal signs aren't lined up. Okay, this equal sign's over here, this equal sign's over here. You got to line up your equal signs. You got to do it. So let's see what we can line up. Well, the x's are lined up already, so we're not going to mess with the x's. And on the right side of the equal sign, you got constants. So we're not going to mess with the constants. But this plus y, it's on the right side of the equal sign. And this plus y is on the left side of the equal sign. So I want to get them on the same side. I'm going to take this first equation, and I'm going to subtract y from both sides. So I'm just going to rewrite it down here. 5x minus y equals that negative 5. Okay. Okay, so I didn't do anything to the first equation as far as changing its value. I simply subtracted y from both the left and right side. So now I have x terms on top of each other, y terms on top of each other, equal signs on top of each other, and constants on top of each other. Okay, that's all I wanted. So now I'm going to ask you, can I add the two equations and eliminate something? I've got minus 5x and plus 5x. So yes, I am going to add these two equations together. So let's add them. Negative 5x plus 5x is 0. Positive y plus minus y, or plus negative y, is also 0. Negative 5 plus negative 5. Be careful, this is where people will make mistakes if they make mistakes. Negative 5 plus negative 5 is negative 10. It's not 0. Negative 10. Simplify the left side, 0 plus 0. Okay. When does 0 equal negative 10? It's an easy question. When does 0 equal negative 10? If your answer is never, it never happens. 0 degrees and negative 10 degrees are never the same temperature. Right? $0 in my bank account and negative $10 in my bank account are never the same bank account balances, ever, ever. Right? That means it's never true. There is no solution. Okay? There was no unique solution because you didn't get something that looked like x equals or y equals. And there weren't infinitely many solutions because you didn't get something that said, 2 equals 2 or 5 equals 5, something that's always true no matter what. Okay? This one is never true. If it's never true, if this is never true, then there is no solution. Okay, let's get the last question. All right, is it set up to eliminate? Well, again, the equal signs are in different spots. So I have to line them up. So I would like to get this 4y on the left side. Okay, so how am I going to do that? I'm going to subtract 4y from both sides of this first equation. Minus 4y minus 4y. Okay, so it cancels this one. So I'm going to rewrite it down here. I get negative x, and now I've got a minus 4y after it. Minus 4y equals negative 8. Okay, so is this set up for elimination? I've got a positive x and a negative x. They are opposites. So yes, I can add these two equations and I'm going to eliminate at least an x. So let's see what we got. X plus negative x, we just said, is 0. Positive 4y plus minus 4y, or negative 4y. That's also 0 equals 8 plus negative 8. That's 0. Okay, so 0 plus 0 equals 0. That is true. When is this true? If you say it's always, it's a W in there. If you say it's always true, then there are infinitely many solutions. Okay? Now, the only other part that you have to say is, okay, there are infinite solutions. That doesn't mean that every point on your graph, okay, is a solution. It's every point that's on that line. So you have to give them an equation for a line that works. Well, you can pick any line here that you want, right? You could pick the line x plus 4y equals 8. It's a good equation, okay? No question about it, it's a good equation. So that's it. Believe it or not, that's it. So if we have an equation that is always true, no matter what the x, y combinations could be, 0 equals 0. Doesn't matter what x and y are, 0 equals 0. Okay, that means that you have infinite solutions. And if they ask you for an equation to show that will give you every single one of those infinite solutions, you pick one of your two equations. Okay? I believe that, you know, sometimes the computer may ask you for, you know, y equals, and you may have to solve for y, but I'm quite certain that in this particular instance, it's just saying, give me an equation. So you pick one of the equations and it works and it's good. Okay, that's it. Day 3's in the books. See ya.